As more and more design firms are doing building information modeling, there can sometimes be a lack of clarity about what processes are possible for collaborating using BIM. Since levels of BIM experience vary across the industry, we are aiming to help you fill in the blanks that you may have about BIM collaboration. Now, when you are involved in a design and construction process that centers around a building information model, you may encounter opportunities to exchange the geometry or data about that project. This exchange can take a number of forms, the typical design-centric ones being that it could be inherent in a process that happens internally in your office as different design team members work on their specialties. For example, building envelope, space planning, commercial interiors, residential interiors, etc. It could be you sharing your design scope's 3D model, data from the model, or both, with consultants for coordination purposes. The same exchange can occur in the other direction too, where consultants share their material with you for coordination of their scopes of work into yours. The sharing could occur at design stages, to coordinate the location and sizes of project elements, at documentation stages, to verify and validate information, or during construction to provide clarification or instructions on the design as on-site construction processes are underway. Collaboration involving a building information model can also occur to assist with scheduling construction, to estimate project costs, and to help with facilities management, though these processes tend to involve builders, quantity surveyors, and operation teams more, and designers less. For this reason, we won't be covering these aspects of collaboration today. One aspect I should clarify at this point is that doing BIM or creating a building information model does not mean using one particular application. There are a number of applications that can do BIM. Following from this, there are also a number of applications and services that enable you to collaborate using a building information model's geometry and/or the data. Today, we are primarily focusing on Vectorworks as the BIM creation or authoring software, and we will mention a variety of others as we discuss collaboration. Now that we have a number of basic concepts in place, let's outline the key ways of collaborating. BIM collaboration can involve one or several of the following ways of working with others. One design team working together on the same building information model. Working on individual BIM models and combining them in one authoring software. Working on individual BIM models and exporting them to IFC to combine in a third-party tool. Tracking and managing issues in the building information model. The first scenario revolves around your own internal design team working on a project entirely within your own office. If you have been working primarily or only in 2D so far, and you have had a number of people work on one design project, you have likely done this by maintaining one Vectorworks file per drawing that needs to be created, i.e., one file for plans, one for elevations, one for sections, etc. This method, and working in 2D in general, doesn't lend itself to BIM because one of the key goals of BIM is to model the entire project in 3D and generate all drawings from that model. In a disparate 2D arrangement, changes that occur to one drawing are not automatically coordinated to other drawings, resulting in considerable amount of manual changes and a high risk of inadequate coordination. The possibilities for collaboration are also limited because of this manual coordination of multiple separate moving parts, and communication disconnected from the Vectorworks files themselves. On top of that, this method usually results in having a lot of files to manage. In some cases, where multiple team members are working on a single project, individual files of different areas are created and then referenced to each other. This technique can accommodate both 2D and 3D workflows, but again, it tends to result in having to manage a lot of files and the relationships between them. One single cohesive 3D model is still not created in this case, so many of the hurdles mentioned a couple of minutes ago still apply. In both of these cases, Offices usually have to establish a separate naming system or other protocol to let all team members know when a file is available to work on and when it is not. These workarounds tend to add unnecessary complication and confusion to the design process. Instead, a better way to develop a design is within a single file and as a cohesive 3D model consisting of geometry and data, a building information model. Vectorworks is well suited to this task. There are many resources at Vectorworks University to assist you with creating a BIM. And if you have a team of people who are tasked with working on that BIM, I propose using a multi-user environment. This allows you to have one single project file for the entire project. The project file is essentially a regular file, but with special permissions and abilities enabled to allow multiple team members to check out and work on parts of it as needed. When each team member opens the project file, a special working file is created in which they can get their work done. Once they have completed an amount of work, they can synchronize their changes back to the project file for all to see. While a multi-user environment is not required for creating the BIM itself, such a system is well suited for collaboration on a BIM process because it enables all team members to work on the geometry and data of a common, complete project model. A good multi-user system will also allow you to set different sets of permissions for each collaborator and log comments about the work performed whenever part of the model has been checked out. All of these contribute to robust control and communication during design collaboration. A multi-user environment like this is often used internally by all team members within one physical design office, as I've just outlined. However, it's important to keep in mind that this same system can be used by remote workers in today's distributed work environment. In Vectorworks, this ability is called project sharing. Other BIM authoring applications have similar features. In terms of sharing a Vectorworks project file with others so they can do their work, there are a number of possibilities. Our own Vectorworks cloud services can host project files and share them with other Vectorworks customers. This will allow multiple team members to design with a connection to the main project file. A number of third-party cloud storage solutions, such as Dropbox and OneDrive, among others, can host Vectorworks project files. Or, if your office has its own dedicated server, then your IT person can install our project sharing server software to help manage and control file access. Now, while what I've described is a great way to work in an all Vectorworks scenario, you may not always have that opportunity. In a case where you are using Vectorworks and your consultants or colleagues are using other software, it is still beneficial to create a BIM yourself for your scope. You can then compile work done by others in their BIM software of choice into a federated model in Vectorworks.
When working with consultants who use different authoring software, all the best practices of BIM collaboration that Neil's mentioned so far are vital to the process. And I'm going to talk about how they apply to this specific scenario. First, let me flesh it out a bit. Let's say that you are the architect on an urban mid-rise building. You're using Vectorworks, your structural engineer is using Revit, and your MEP engineer is using AutoCAD. And you want more coordination between consultants than you would get in a traditional 2D workflow. The first principle of BIM collaboration to consider is planning. The process of creating a BIM execution plan is just as helpful as the document itself. The first question that a BIM execution plan should answer is, why do the project in BIM? If it's because the client requests that the project be BIM, that comes with specific expectations and deliverables. If it's because you want more coordination and you want to be competitive with other firms, then that is worth stating in the BEP as well. I recommend that the BEP is created by you, the architect, as architects usually take on the project management role anyway, and the project usually begins with the architect. Within the BEP that includes sharing models created in different software, it's important to not only establish internal processes and protocols, but also a few specific standards for everyone, no matter their authoring software. These standards are: establish a universal project zero before models are created. This is important for combining models, and doing this saves a lot of time down the line in the coordination process. This project zero should be described and diagrammed in the BEP. If you're using Vectorworks, the project zero can also be shared automatically with your consultants by creating a Vectorworks file that has at least a ground floor story and is georeferenced. Georeferencing establishes the XY coordinates of the project zero, and the story establishes the Z coordinate. Once those aspects of the file are established, you can draw as little as a single wall to create geometry to export. You can then export this file to IFC or even a georeferenced DWG and share this with your consultants. They can import the file and use the file's coordinates to set up their project coordinates. The second specific standard is to decide what software version everyone is using and keep using that version if possible for the entirety of the project. This version also includes the IFC version that will be used. This streamlines the process because this type of collaboration involves each consultant exporting to a different file format multiple times. So the fewer variables and changes to that particular workflow, the better. The third specific standard within the BEP is to decide how often models will be combined for review and coordination. It helps to set a schedule and manage expectations. The BIM execution plan is vital to planning, but so is having a point person, hopefully a dedicated BIM manager, to facilitate communication between consultants. Communication is key to this scenario, especially if this process is new to you or to any of your consultants. The BEP should be reviewed and approved by all consultants, and I recommend that this be done in a face-to-face or video meeting. I can't stress enough how important it is for everyone to be on the same page and to be as comfortable as possible with the process. The majority of issues and headaches I've witnessed with the BIM collaboration process stem from one or more parties feeling anxious or uncomfortable with trying something new. And the best way to avoid this is communication, communication, communication. Once you start your work on your design in Vectorworks, it's important to think about file setup. Both you and your structural engineer will be creating IFC files that will need to be coordinated. I'll get to collaborating with the MEP engineer using AutoCAD shortly. When sharing the model itself, and not simply drawings extracted from the model, there needs to be a certain level of accuracy, consistency, and organization. The specific level of accuracy can be outlined in your BIM execution plan, but I think it makes sense to create a model to the level of detail that will be seen in your plan and elevation drawings. Anything of higher detail can potentially be created by overlaying 2D detail on a model viewport or drafting completely in 2D. When it comes to file organization, using stories in Vectorworks greatly streamlines the IFC workflow. When your file uses stories and your layers are mapped to those stories, the IFC export is super simple. When any changes are made to the design that affect story height, it's straightforward for both you and your structural engineer using Revit to make those changes in your own models and keep the design coordinated. Besides stories, the other file organization principle that is vital to the IFC workflow is to use built-in plugin objects whenever possible. Walls, slabs, doors, windows, railings, stairs, etc., all have IFC data attached by default. If you use these objects, you don't have to do any extra work to export to IFC. The way IFC works and why it works for different software is that the data makes the object. It doesn't matter what type of 3D geometry a wall might be made of in its original software. If it has IFC wall data attached to it, it's a wall in the IFC file. Simple as that. Since wall objects in Vectorworks have IFC wall data attached by default, any walls in your Vectorworks file will be walls in the exported IFC file. If you do need to create custom objects, it's easy to add IFC data to those objects. If you want to learn more about IFC in Vectorworks, you can read Sharing Your Model with IFC, an Introduction on Vectorworks University. Once you have your IFC model, there's a lot you can do with it. But in this scenario, where not everyone is creating an IFC model, it makes sense to simply use it for reference and for coordination meetings. You can send your IFC model to your structural engineer. They can link to the IFC in Revit, and then you can have your architectural model within their file for reference purposes. You can do the same with their IFC model by referencing it into your own file. The IFC models become valuable design tools for each of you. Either you or the structural engineer can tour the model in coordination meetings, either in Vectorworks or Revit. You can discuss the design and manage issues as they become apparent. I'd call this scenario manual coordination, and I think it's a great first step and a reasonable expectation when just getting started with BIM collaboration using multiple software. There are more automated methods of coordination, and Luke will discuss those in the next scenario. So how does the MEP engineer fit into this scenario? In addition to exporting your model to IFC, you can also export your sheets as DWGs, and your MEP engineer can do the same. You can reference their DWGs in your model, and you can see all three models together, at least in plan view. Perhaps your MEP engineer will see how efficient it is to compare IFC models in your coordination meetings, that they are inspired to upgrade to BIM software. I've already talked about file organization that is optimized for IFC export, but something that also needs to be considered when creating DWGs is Vectorworks classes. It doesn't matter what standard you use, as long as you stick to it. It's important for your objects to be classed logically and consistently, because it produces DWGs that are much easier for your consultants to manage. Referencing IFC models and DWGs from consultants can be a great way to see immediate benefits from a BIM workflow. To make it easier to control the visibility of your reference files, I recommend using layer referencing in Vectorworks. This isn't the default, so it must be changed in the reference settings before referencing a file. But layer referencing means that each story of an IFC file will come in as a reference layer. Each DWG will also be on its own reference layer. Those layers can be incorporated into saved views, so you can easily see all three files on a per floor basis. You can also create viewports that incorporate geometry from all three files if you wish. Because this form of referencing creates classes as well, it's important for your MEP engineer to organize their files well. This is not really an issue with referencing an IFC file because the classes that are created are IFC object types, so it's already standardized. At the project's completion, you'll have similar deliverables as to a project drafted in 2D, a printed drawing set. The difference will be how you got that result, and in all likelihood, many fewer change orders and RFIs to deal with.
I think what Sarah just reviewed is a great example of how you can approach a more realistic implementation of a BIM process. It can provide the best outcome for your projects as you can define your own goals for using BIM on your own projects. As this illustration shows, the first step to take is to define what you want to achieve using building information modeling. And as you get more comfortable with the process and realize its benefits, you will start adding various processes and analysis to even go beyond your initial goals. In my opinion, it is a better approach because it better prepares you for undertaking projects that have predefined BIM requirements. In a scenario where you are getting a request for proposal from a potential client for a new project that includes BIM, what would you do if you haven't taken that first step? You could still do the project, yes. Will you be successful? Maybe. One thing you must know when taking on a BIM project is what the owner's goals are with using BIM, and second, what the BIM requirements are. Answering those questions may help you make the decision to embark in this endeavor. Ensuring a fully coordinated model to reduce errors and better control the budget faster delivery process, faster construction? Do they want to manage the build assets? What information do they need? Many benefits can be realized with building information modeling. And going back to Sarah's discussion on the BIM execution plan, the client may or may not have a well-defined plan. Let me bring this back to the workflows for a complete BIM collaboration process. For delivering a fully coordinated BIM model, whether it is a requirement defined by your client or by choice of your own, you will most likely be using a combination of manual or visual coordination, like Sarah showed you, and a software that will assist in automating the coordination of various models. The last component, but an important one for achieving an effective collaboration workflow, is how you will communicate and keep track of the coordination issues. The process for model coordination is often called clash detection or model checking. For this process, you or someone on your team will use a specialized software, perhaps Navisworks or LibreOffice. But there are plenty of other tools available for this as well. Ideally, this would be laid out in a BEP. The process will require an exchange of IFC files from all involved in the design of the project. You should always combine the IFC files with your Vectorworks model. This will give you a chance to visualize coordination issues directly in your design environment and allow you to make the appropriate changes to resolve issues. The clash detection process will happen in parallel using a different software. In this example, I'm using LibreOffice. This is a rule-based automated process that verifies the model and looks for conflicts between the various models' geometry and data that comes with each object. Note that if you are managing the process yourself, meaning that there is not a BIM manager that was hired by the client, you will need to own this software. With Vectorworks, you can connect your models directly in Solibri, which will make the process even more streamlined. You can see in this example that the rule set was to check for clashes between MEP and architectural models. The second example is a rule set that checked only the architectural model to find issues like clearance between building elements. This type of check is often referred to as model validation and can be used to verify specific requirements for life safety and model integrity. After you run a check, you can start reviewing the various coordination issues. The second part of the collaboration process, and probably the most important, is how you communicate and manage all coordination issues you find. The automation of the process is great, but it can also generate a lot of issues. In the coordination process, it is important to review the relevant clashes for any given phase of the project. For example, you may use different rules for different phases, or perhaps you can omit the verification of certain elements that you know are still being designed. The point is that you can control these when you manage the process. Sometimes you may not have that control when this process is done by a construction manager. Issues or coordination issues can be created from the model checking process or from any BIM authoring software like in Vectorworks. We'll get to that in a moment. An issue will look like this. It will identify the object that are in conflicts and automatically write a title and description. And it will locate the objects in a model and create a viewpoint. Those are the basis of an issue. You can assign a team member for its review. You can then tag the disciplines that needs to review it. And you can assign dates and status, etc. Each issue can be added in a report, an Excel file or a PDF file. It can also be saved as a file format that can be exchanged. The file format is called BCF, or BIM Collaboration Format. Thankfully, this workflow can be greatly improved when using tools specifically designed to manage these issues. These tools are cloud-based and are, in most cases, based on the BCF file format, which means that they are compatible with most model checking software and BIM authoring software, including Vectorworks, Revit, Navisworks. The key to the complete BIM workflow is to have the ability to connect all of these tools together, to manage and keep track of these coordination issues efficiently. A web service like BIM Collab or BIM Track, for example, is like a database where all issues are managed. Benefits in using these types of services are, one, a more transparent process. It's data-driven, so you can get reports out of it. You can set various types of permissions for viewing or editing, giving better control over changes required. And then lastly, it can be accessed by everyone involved in the project, including the client. Vectorworks has an integrated tool called BCF Manager. The BCF Manager lets you create issues directly within the design interface. You can save to a BCF file to exchange with your consultants. This would be perfect if you are in a scenario similar to what Sarah reviewed previously. Or from the BCF Manager, you can directly connect to a cloud-based BCF service where all issues are managed. When connected, the issues are synced between Vectorworks and the BCF server. You can create new issues or review issues and make changes as needed in Vectorworks. This allows everyone collaborating on the project to see in real time, while using the web service, when issues are resolved or created. To close the loop, model checking software can also sync issues created during the coordination process. In Solibri, you can also connect to most BCF server. This allows a seamless collaboration workflow between your BIM authoring software and coordination software. The following example shows you this workflow by connecting both Vectorworks and Solibri to a cloud-based BCF service. Issues created in Solibri are directly connected and synced to the cloud-based BCF service and synced back to Vectorworks via the connection between Vectorworks and the BCF server. In Vectorworks, you can review the issues, make a change to the model, resolve issues, or create new ones. All changes you make will then be sent back via the BCF service to your consultants. This workflow simplifies the file exchange process. I like to call this the complete BIM workflow, because you can design in your BIM software of choice, coordinate the model using a model checking software, and effectively communicate or manage all issues during the design phases.
Thank you so much, Sarah and Luke, for sharing your great insights and experiences on these processes. And there you have it, the essentials of what you need to know for BIM collaboration. With the information we have shared, you can assess your options for collaborating on a BIM project and determine what process will work best. Working with others, with a building information model at the center of your work, is a continual learning experience, but I hope we have expressed how valuable a process it is.